Hello, friends. I welcome you all to Only Code. I'm your host and host, Rahul. Let's get started. In this video, we'll be diving into the topic of collections in Java. We will start by answering the question, what is a collection in Java? And discuss why collections are important in Java. From there, we will explore the different types of collection in Java. Next, we'll break down the basic concepts of Java Collections Framework. And finally, we will discuss about Java collection interfaces. So, let's begin. What is a collection in Java? A collection in Java is simply a container that holds multiple objects or elements. Think of it like a shopping cart that can store things like fruits, vegetables, or household goods. In Java, collections help us manage group of objects, whether it's adding, removing, or accessing them. The Java collection framework provides tools to store and manipulate these elements efficiently. A grocery list or only code subscribers are good example of a collection. Collections were introduced in Java JDK 1.2 and onwards. Before that, we had arrays, vectors, and hash tables for storing and manipulating collections. Now, let's talk about why we actually need collections in Java. When we work with data, we often need to store groups of items, like a list of numbers, names, or objects. One option in Java is using arrays, but there are some limitations with arrays. Fixed size. Once you create an array, its size is set. If you want to add more items than the array can hold, you would have to create a new array and copy everything over, which is not efficient. Limited features. Arrays only allow us to store and access data. What if you need to sort the data, remove some items, or search for specific values? Array don't have built-in method for these tasks. This is where collections come into play. Collections are much more flexible and powerful than arrays. They offer dynamic size. Collections can grow or shrink as needed, meaning you don't have to worry about running out of space. Built-in methods. Collections come with methods that make it easy to add, remove, search, sort, and manipulate the data in various ways. Flexibility and power. Collections allow us to handle complex data structures like lists, sets, maps, and queues without writing custom code for every operation. In short, collections give us more control over data with much more convenience than working with arrays. Basic concepts of Java Collections Framework. The Collections Framework in Java is essentially a big container that includes a set of tools and data structures to store and manipulate groups of objects. It provides standardized interfaces and classes that allow us to manage data more efficiently, whether we are working with lists, sets, maps, or queues. The collections framework makes it much easier to store multiple objects, retrieve them quickly, sort, filter, and manipulate them using pre-built methods. It is a toolbox. Instead of creating your own custom storage solutions for every piece of data, there are a few key operations that you will frequently use when working with collections. Storing data. Collections allow you to easily store data. You can add an element using the add method. Retrieving data. Collections give us various ways to access elements. You can get an element by its index using the get method. Removing data. Collections offer several methods for removing data, like remove method to remove an element by value. Manipulating data. The Java Collections framework also provides various ways to manipulate data. You can sort, shuffle, reverse, or even search through it. For example, the collections.sort method can help you sort an element in a list, and collections.reverse can reverse the order of a list. These basic operations, sorting, retrieving, removing, and manipulating, make it much easier to work with groups of data in Java. Collections come in different forms, each designed to solve specific problems depending on how you want to store and manage your data. The main types are: first, collection. Collection by design do not maintain any specific order and they allow duplicates. It's the root of all collection interfaces. Many other collections like ArrayList, HashSet, and linked list implement it. Lists. Lists are ordered collections. The order in which elements are added is preserved. Lists also allow duplicates. This makes them useful when the order or ability to access elements by index is important. Common implementation of list includes ArrayList and linked list. Set. A set is unordered and does not allow duplicate elements. If you try to add a duplicate item to a set, it simply won't be added. Sets are perfect when you want to ensure uniqueness without worrying about the order of elements. The most common used implementation are hashset and treeset. Queue. A queue follows the FIFO, first in, first out principle, meaning the first element added is the first to be removed. Queues allow duplicates. This makes them ideal for situations like task scheduling or processing items in the order they were added. The most commonly used queue implementations are linked list and priority queue. Maps. Maps do not follow the same structure as other collections, as they store key value pairs. The keys are unique in a map, and it does not matter if the values are duplicated. Maps are particularly useful when you need fast lookup by a specific key. Hashmap and tree map are popular map implementation. Let's look all of these in details. Let us now look at the Java collection framework hierarchy. At the top, we have the collection interface, which serves as the root for most of the collection classes in Java. From there, we have three main sub-interfaces: list, ordered collections that allow duplicates, like ArrayList and linked list; set, unordered collections that don't allow duplicates, such as HashSet and TreeSet; queue, a collection designed for holding elements in a specific order, typically FIFO, with implementations like linked list and priority queue. There is also the map interface, which is not part of collection but is still a key part of the framework. It stores key value pairs with implementations like hashmap and treemap. Now, let's look at all Java collection interfaces one by one, starting with the collection interface. Collection interface is the root interface in Java collections framework. It serves as the foundation for more specialized collections, such as list, set, and queue. Collection allows duplicates by default. However, collections like set don't allow duplicates. By design, collection does not guarantee any specific order of elements. For example, hashset is unordered, while ArrayList guarantees insertion order. Common methods defined in the collection interface are: add, adds an element to the collection; remove, removes the specified element; size, returns the total number of elements in the collection; clear, removes all the elements from the collection; contains, checks if the collection contains a specific element. Common implementation of collection interface include ArrayList, which allows duplicates and maintains the insertion order. HashSet, which does not allow duplicates and is unordered. Linked list, which allows efficient element insertion and removal from both ends. List interface. List interface represents an ordered collection. This means elements are stored in a specific order and the order of insertion is preserved. List allows duplicates, meaning multiple occurrences of the same element are allowed. The key feature of a list is that it provides indexed access to elements. This makes it easy to retrieve, modify, or remove elements based on their index. Some common methods in the list interface include add, adds an element to the list. Remove, remove the element at the specified index. Get, retrieves the element at the specified index. Set, replaces the element at a specific index. Size, returns the number of elements in the list. Some common implementation of list include ArrayList, which is a dynamic array allowing duplicates and preserving insertion order. Linked list, which is a doubly linked list that allows for efficient insertions and deletions. Set interface. Set interface represents an unordered collection where insertion order is not maintained. The order in which elements are stored or retrieved is not predictable. Set guarantees uniqueness. If you try to add a duplicate element, it will not be added. Some common methods provided by the set interface are add, adds an element to the set. Remove, removes the specified element. Size, returns the number of elements in the set. Contains, checks if an element exists in the set. Clear, removes all elements from the set. Two of the most common implementation of set are HashSet, which ensures uniqueness but does not maintain any order. TreeSet, which is a navigable set and keeps the elements sorted. Queue interface. Queue interface in Java represents a collection designed specifically for processing elements in a FIFO, first in, first out order. The elements in a queue are processed in the exact order they were added. A key characteristic of queue is that it allows duplicates. This means the same element can appear multiple times in the queue. Common methods in queue interface include add, adds an element to the queue. Remove, removes and returns the front element from the queue. Peek, returns the front element without removing it from the queue. Offer, adds an element to the queue if space allows and returns false if it cannot be added. Poll, removes and returns the front element or returns null if the queue is empty. The most common implementation of queue include linked list, which implements both list and queue interfaces and provides an efficient way to add or remove elements. Priority queue, which stores elements based on their priority. So, the highest priority element is processed first. Map interface. Map interface represents a collection of key value pairs which is ideal for tasks requiring association between keys and values. In a map, keys are unique. If you add a key value pair with an existing key, the previous value for that key will be replaced. Map interface does not extend the collection interface. Instead, it operates with key value pairs, making it distinct from other collections like lists or sets. Some of the common methods in the map interface are put adds a key value pair to the map, get retrieves the value associated with a specified key, remove removes the key value pair for given key, contains key, checks if the map contains a specific key, contains value, checks if the map contains a specified value. The most common implementations of map interface are hashmap, which allows null values and keys and does not maintain any order. Treemap, which stores keys in sorted order and does not allow null keys. Moving on to the code example, and here we'll cover the collection interface and the map interface. Starting with the collection, we'll create a collection named list equals to new array list. As collection is an interface, so we cannot create an object from that. So we have to use an implementation of collection. Here in this example, we are using ArrayList. The first method we have is add, adding an element to the list. Here we'll be adding one element, an integer 1. Let's add few more elements. Only code, and let's also add a float 2.35. After this operation, we'll print the list. Let's run this particular code. We can see that 3 elements are added to list, 1 only code and 2.35. Let's now check another method, remove. List.remove 2.35. We'll print the list after this operation. If we rerun this, we can see the second list that is printed is having only 2 elements now. 2.35 is removed from the list. Next method is size, which returns the size of list. At this point, the size of list is 2. We'll expect an output of 2 from this statement. Let's rerun. We can see list.size is returning 2, which is correct. Next method is contains. We'll print list.contains only code. It should return true, and let's try to search for an element which is not present. Hello. Let's rerun the program. The first statement returned true because the list contained only code, and the second statement returned false because hello was not present in the list. Last method we'll see in this example is clear. List.clear. It should remove all the elements from the list. Let's print the list after that. Rerunning the program again, we can see that the list has become empty now. List, set, and queue behaves in a similar way. So let's move on to map example. Let's create a map object named map equals to new hash map. Again, map is an interface and we cannot create an object out of that. So we are using here an implementation of map, that is hash map. The first method we'll cover here is put. Map.put, we have to add a key value pair 1 comma, only code. So the key is 1 and the value is only code. Put 2.35, comma, hello. We added a value of hello corresponding to a key 2.35. Let's put one more key, secret 792. Let's print the map. Running this file, we can see that map contains three key value pairs. Secret key is mapped to 792 value. Key 1 is mapped to only code and key 2.35 is mapped to hello. As it can be seen in this example that the insertion order is not maintained. We inserted 1 as the first key, but when we printed the map, the first key printed is secret and not 1. This order is not predictable. Let's move on to second method, get. Get pulls out a value corresponding to a key provided. Map.get 1. It should pull out only code. And let's try to get something which is not present in the map, 25. The first statement gave us only code which was mapped to the key 1 and the second statement gave us null because 25 was not present in the map. Next method we have is remove. Map.remove secret, printing the map after that. Now only two elements are present in the map. Next method is contains key. Map.contains key 1 and map.contains key 72956 something, some random value which is not present. Okay. The first one returned true and the second one returned false as expected. The last method we'll cover here is contains value. Map.contains value only code. The last statement returned true because the key only code was already present in the map. Thanks for watching. That's it for this video. Don't forget to like, share and subscribe. We'll see you in the next one.